I am Ennemcien. Let us see basics of properties of matter, elasticity, mainly elasticity. Before that, I'm going to give you some important formulae connected with conduction of heat. Conduction of heat and elasticity, we can connect them together in various problems. Now, the basic formula for conduction is the amount of heat conducted in 1 second or rate of conduction of heat, Q. Q is the amount of heat conducted in 1 second. This is equal to K or kappa, K into A into T1 minus T2 by L, where K is the coefficient of thermal conduction or thermal conductivity. A is the area of cross section of the material. T1, temperature of the hot end. T2, temperature of the cold end. L, length of the material. So heat conducted in T seconds can be obtained by multiplying this by T. This is the heat conducted in 1 second. So this is the first formula. This is called Fourier law of conduction. Next, second formula. We combine two conductors in series. Both conductors have same length, same area of cross section. This is the hot end, this is the cold end. This is the junction or joint of the two conductors, where there is a common temperature T0, junction temperature T0. T0 will be less than T1 and T0 will be greater than T2. Now heat conducts from this hot end to this cold end through the junction. Definitely at steady state, heat conducted by this block will be equal to heat conducted by this block. I think that I have introduced this earlier. Anyway, we can see the formula. In such a case, the junction temperature can be found out by this formula. You can remember it because it is very essential in entrance exams, etc., competitive exams. T0 equals K1 T1 K1 T1 plus K2 T2 by K1 plus K2, where K1 and K2 are the thermal conductivities of these two materials. This is the formula for the temperature of the junction of the two materials. Next formula is the two conductors have the same area of cross section, but lengths are different. This is of length L1, this is of length L2. And we heat the junction, and these two ends are maintained at a constant lower temperature T0. And this junction we heat up so that T is higher than T0 and this T0. Then heat will conduct from the junction towards this end and towards this end. If these two heats conducted are the same, then we can form this formula. K1 by L1 equals K2 by L2. Because in the general basic formula, L comes here, denominator, K in the numerator, area on the numerator. Keep it in mind. So K by L is constant because T2 is T0 here. T1 is T. Q is the same. That means K by L is a constant, or K1 by L1 equals K2 by L2. Next case, A is different. Area of cross section is different, but length is the same. This junction is heated up. We are heating this junction. So junction is at a higher temperature T. Two ends are at temperatures T0. T0. Area of cross section of this is A1 and area of cross section of this bar is A2. Now if the heat conducted to this direction and heat conducted to this direction are equal, then we can write K1 A1 equals K2 A2 because A comes in the numerator. So K into A must be a constant. K1 A1 equals K2 A2. This is the formula. Another point. Effective thermal conductivity when two blocks are joined in series. I think I have taken this portion. I have derived it. K equals 2 K1 K2 by K1 plus K2. Provided length is the same, area of cross section is the same. This is hot end, cold end. Heat is conducted in this direction from hot end to cold end. Then the effective thermal capacity of this combination is 2 K1 K2 by K1 plus K2. Another case is parallel combination. These two blocks are, one is placed above the other. This is the hot end, cold end. Area of cross section is the same for both. Length is the same. Then equivalent K is K1 plus K2 by 2. These are the important formulae connected with thermal conduction.